Hi, Amy. How are you doing?
Hi, sir. Yeah, I'm good, thank you. How are you?
Very good, very good. So, Amy, we are doing a lot of practice on these mock test papers. How do you find
Right.
this process of learning?
Like, super helpful. And like, I've known from like every teacher, and you always tell me the only like best way to revise after learning the content is obviously exam questions because that's what you're going to get in the actual exam. Similar layout, similar setup, and even looking at the marks. So, just I guess the best way to get the best mark in the exam is to do these questions. So,
Good.
it's definitely helpful for everyone, just knowing different strategies, different methods, and also, our technique where you look at the marks and then see, is it relevant to the method, is it like the correct like working out, because imagine if it was only 3 marks and then you do like a whole thing, it's quite time wasting. So we need to find maybe a couple shortcuts and stuff, so it's really helpful. So
Okay.
yeah.
And we have also observed, looking at about 10 years of past papers, that the pattern is repeated.
Mm.
And we have similar type of difficult questions. I'm talking about when we say difficult questions, questions involving calculus, which has derivatives and integrals, they are
Yeah.
difficult. And the questions involve trigonometry with algebra, that becomes difficult. Calculus, the questions that involve logarithmic and exponential functions with some application makes them very difficult. Similarly, the equation of circle in standard form can be asked in many different ways. So these four topics are actually difficult topics as far as your curriculum goes. We had a
Right. Yeah.
focus on this, and in most of our videos, we are trying to take at least one example of each kind. So, Amy, if today
Yeah.
also you could pick up some examples of these kinds, it will be great for us.
Okay.
Yeah, you can share the screen.
Yeah, so I've had a quick like look through this kind of file with a couple of exam questions here.
Mhm.
So I'm just, like you said, I'm just going to pick maybe a couple from each topic.
Sure.
So yeah, this is the first one to do with proof. So
Correct.
yeah.
Yeah, prove. We haven't proved
So,
anything for a long time, right? So,
no.
can you please read this question? We'll try to prove it.
Yeah. So prove that if a to the power of x equals b to the power of y equals ab to the power of xy, then x plus y equals 1.
Correct. That is what is to be proved, right? So we have a to the power of
Yeah.
x equals to b to the power of y, and that is also equal to their product, which is ab, and the exponents are xy, right? Okay.
Mhm.
Very interesting. And we need to show that if that is true, then x plus y should be equal to 1. Only then it is true. This is the kind of proof, right? How do you
Right.
think we should approach to solve this question?
So I remember like when you were teaching me all about proof, there were like different ways of solving proof. I always find this topic the hardest, and like it looks like it's easy, but it's actually quite tricky.
Yes,
So this one you can do like proof by counterexample. There is proof by exhaustion.
yes,
There's proof by another one. But I think in this case, because you always said that whenever they say prove that if, it means the statement they've given is true.
yes,
So you have to assume that it's not, maybe. So where it says prove that if the ax plus b, let that say the same, and then it says x plus y, sorry, equals 1. Make that x plus y not equal to 1, and
yes.
then maybe you could go from there. I don't know.
Yeah, you could do like that. That's
Yeah,
a good
I think that's
strategy. Yeah,
how
but
I approach it.
yeah, let's look into this example once again. It says prove that if this is true, then that is true.
Hmm.
If this is true, then that is true. That is the kind of thing. So you could write an equation and prove it by counterexample. However, in this particular case, what I feel is, I mean, the gut feeling which I get is, we are saying if this is true, we'll assume this is true. Then we will derive a condition that always x plus y is equal to 1. So we could derive it looking into that equation by taking logarithms.
Oh, okay.
Why did we go for logarithms? Because that is the inverse function, right?
Of
So inverse function of exponential function. So we are deriving at an equation which is kind of algebraic in nature from exponential equation. So I think if we take logarithms, then we can bring the terms in terms of x and y, and we can get this part proven. It's like a trigonometry proof. You understand? Like trigonometry, we prove left side equals to right side. That goes
Yeah.
like that. So we'll kind of
Oh.
follow that kind of strategy, right? It's like you follow in trigonometry. Correct, kind of like this. But we are left side here is all this is true, then that should be true. I mean, it's a kind of different, but starting from what is given to us to what we need to figure out. So that is the kind of strategy which I thought we'll apply and then see the result. Is it okay?
Okay.
So let's try to do it. Now, we have a couple of variables here. So we can split this equation. Let me write this equation as, let me change the ink here. Okay, so we have a to the power of x equals to b to the power of y as one of our equations, correct? So we are using this particular equation and coming out with a relation between x and y, because basically we want a relation between x and y. We do not want a and b, correct? So we have to eliminate a and b. So the process is, strategy is what?
Must eliminate a and b because it's not in the x plus y equals 1 section.
Correct. Both a and b have to be eliminated. So if I want to eliminate both a and b, I need two equations.
Oh yeah. So like simultaneous maybe.
Yes, because there are four variables, correct? A, B, X.
Right.
Because there are four variables, because we have A, B, X, and Y. So we want only two and not the other two. You get the point. So to eliminate two, we need at least two equations. So we'll work on the given equations in a way that ax to the is equals to this, and we can also work on a to the power of x equals to the other part of the equation, which is ab to the power of xy. Is that clear to you?
Yeah.
So we'll work on these two equations to eliminate a and b. That is the strategy to get x and y. Is it okay? How do we do that? So to do this, we are going to take log both sides. So we'll take log to the base a. Since this is base is a, so I'll take log to the base a of x both sides. And I should not write x, we'll see. So we'll write this as log to the base a of a to the power of x equals to log to the base a of b to the power of y. Is this step clear to you? Take log to the base a on both the sides.
Wait, why didn't you take log b? It doesn't matter.
Yeah, you could have taken log b.
Oh, okay.
Let's take log a, because second equation, if you take log b, then we'll take the second equation as b to the power of y equals to this, right?
Okay.
I took the second one also with a, so I'm taking log to the base a, okay?
Right. Okay.
Now, once I do this critical step, now I need to solve for it. Using the power rule, I could write this as x times log to the base a of a equals to y times log to the base a of y.
Of b.
What is log a of a?
Oh, b, sir. Log a of b.
Oh, sorry. Log a of b, yes.
Log a of a is 1.
Log a of a is 1. So log a of b, correct. So log a of a is 1. So we get x on the left-hand side equals to y times log a of b. Is that correct?
Yeah.
So that gives us one of our equations, which let me write in a box in terms of x, y. So I'm writing this equation as x over y equals to log of a, b. Is that clear to you? So I'm dividing by y on both sides. Is that okay?
Wait, why are we doing that, sir?
Isolate xy. We have to get rid of ab, right? So isolated xy and ab on the other side. Do you see that?
Okay.
So the ratio xy is log to the base a of b. Do you see that? How I'm writing this?
Yeah, right.
Now on the other side also, I will do the same, and which is I'll take log to the base a. We get a to the power of x equals to log to the base a of ab to the power of xy. Now, left side is x, right? let me rewrite log to the base a of a, and this is xy times log to the base a of ab, correct? So the left side in this case is also equal to x, and on the right side we get xy log of. Now we can apply the product rule, right? So it is log of a plus log of b, correct?
Oh yeah.
Using the product rule. Now, as you can see, we have xx which can be cancelled. And so what do we get from here? 1 equals to y times, what is there in the bracket? Log a of a, which is 1, right? Plus log a of b. Now, what is log a of b? So we are eliminating a and b. Do you see? Log a
Oh,
of b
x
is
over y.
1 equals to
So
y
you put
times
x over y.
1 plus x over y. Is that clear to you? Now you open this bracket.
Oh,
So when you
so
open
y plus x.
y plus x, which is same as x plus y equals to 1. Do you see that?
Oh yeah.
So we
Whoa, that's kind of
eliminated,
hard.
yeah,
Yeah.
we eliminated and got our answer as x plus y equals to 1. So like a trigonometric approach, so not like by counter example and not by contradiction. So we have strategies to prove, and this is one of the best strategies, straightforward, correct?
So how
Yeah.
do you know whether to do this if it came up, or like how to do like a counter example? Because in school when we learned like a, so if a is something then b is something, they always said
Correct.
you have to say a is something then b is not that thing.
So
So how do you
I
know?
will put it very simple, Amy, and that is, if we are talking about plain and simple English, then counter examples and those things work. When,
Okay.
but
Yeah.
when we get into hardcore mathematics, they don't
Yeah.
work. They don't work because
Okay.
converting that hardcore things into mathematical language or vice versa is very difficult. Simple statements, x times y is equal to 5. Everybody is writing
Yeah.
x, y equals to 5 statement. They say, oh, how easy it is to write an algebraic equation
Yeah.
or a phrase or a sentence or whatever, right?
Yeah.
It is not that easy. It is only easy for very simple statements. So if
Right.
you have a very simple statement, right, which you can easily understand and mathematically translate, then
And
use
it's logical. Yeah.
contradiction and those things.
Okay.
Otherwise,
Yeah.
don't.
So otherwise it has to be solved like that trigonometric approach, left hand side equals
Yes,
right hand
yes.
side. Okay.
So if there's something, well, this is the highest number. Oh, this is very simple statement. You can understand it, right? You can, no,
Right,
this is not the highest number. I have number plus 1 as a greater than.
Yeah, so
So it
counter example.
contradicts. Yeah.
Yeah.
So you could say that, correct? So only those simple statements, for them, those approaches are very good.
Oh, right. Okay. Yeah.
Sometimes proving those statements or making them contradictory becomes very difficult mathematically. So giving one example,
Yeah.
where is a tangent always touches the curve at one point. You say, no, it is not the case. If I have this particular graph, I have a tangent which is touching at 2 points. So it is done,
Oh,
right? So we have
yeah,
shown
yeah.
that this statement is wrong. You get the idea.
Right.
But
Yeah.
to prove this is so difficult.
Yeah. If you're trying to do it that
So
method, so it has to be.
counter example works. Therefore,
Oh,
yeah, many times for very difficult statements, which you see, visualize, and which you have examples for, why to break your head? Provide that
right.
example, correct?
Yeah, because I've never seen obviously this kind of question before, so it has to be some
Yeah.
mathematical approach when you have to answer it. Okay.
Mathematical. So have you taken a picture of this? In
Yeah,
fact,
yeah.
you upload the video, you'll understand. So
Yeah.
can you explain this particular process, and then we'll move on to the next question, Annie?
Yeah. So I guess we were just kind of discussing how when I started off the approach, I thought it was one of those counterexample questions, but obviously it's not one of them straightforward statements. So we used basically taking logs on both sides, and we're trying to make basically the right hand side, which is the a to the power of x equals b to the power of y. We're trying to get two equations, because initially when you're looking at the last part, which is then x plus y equals 1, there are only two variables present, but as total all the variables that are present are 4, so
Correct.
we only want 2, so we need two equations to eliminate a and b.
Correct.
So with that kind of method in mind, we took logs on both sides, and then we found two equations. So one being x and y over equals log base 8 of b, and that was one equation there. And then when we did it again for a to the power of x equals ab to the power of xy, we again used the same approach, but we using the log rules, we found that log base a of b came up, and we already found a value for that, which was x over y. So we substituted that in and then got the answer on the right hand side.
Perfect. So this is a very important question, slightly difficult, right? Good, you got the understanding of this question. Now let's move on to the next. Let me erase this.
All right. I know these questions don't show.
What does E mean?
Yeah, I was just want to say, so they don't show marks, but when I did look at the mark scheme for these, I think this question was like 8 marks or something.
8 marks, oh my God.
8 marks, yeah. So it's a bit ridiculous. Yeah, I have looked at the marks for these questions that we're going to do. Okay, I'm just going to quickly go through some.
Yeah, we are avoiding the logarithm. We can take circle. Yeah, okay, next. Okay, you must have said.
I think there was a particular circle one that was pretty good. So
I see. Okay. Okay.
That.
You're looking at the hardest questions. That's good.
Yeah.
Okay, read the question, please.
Okay, so the circle C has equation x squared plus y squared minus 4x minus 6 equals 0. And the line L has equation y equals 3x minus 6. Part A, show that L passes through the center of C.
Okay, so we are given a circle C with standard form equation. You are an expert by now how to get the center, right? And we are given equation 9, which is coming from minus 3x to this, and it passes through the circle. So I assume the statement is correct, and let me pass this line through the center of the circle. Now tell me what. First, show that the line passes through the center C of the circle, right? So what is the point C? Can you tell me what is point C?
Is it 2, 0?
Yes, 2, 0 is correct. How did you get 2, 0? Because
yeah, your method. Well, the method, you know, the formula method.
Yeah, general equation is.
Sorry, yeah, 2fx plus 2gx.
Right, so the center basically is center C will be minus of f minus of g, correct? So in this particular case, sorry, this is y. Sorry, yeah, that is y, correct. So the coefficient of x, half of that, and coefficient of y, half of that, is the center point with a negative sign. Do you see that? So we have minus 4. Half of minus 4, right? So minus 4, half with a negative sign is the x value. And as far as the y component is concerned, that is 0, right? So the minus of that, and that gives you the answer, center as 2, 0, correct? Yeah. Otherwise, you can complete the squares, right?
Oh, yeah, yeah.
To find center.
If you, forgot the formulas.
So very simple in this case. So I'll quickly do it, right? It doesn't take much time, but benefit of for other students. I think it is important for me to take this up. Okay, so I'll write this as x squared minus 4x, combine the terms, right? Y squared minus 6 equals to 0. Half of 4 is 2. So we'll add and subtract 2 squared, completing the squares method. Do you understand?
Yeah.
And as far as y squared is concerned, we do not have any other component with this. We'll leave it like that. So that gives us x minus 2 whole square and plus y square. And this minus 2 square, I'm writing as minus 4, and we have minus
4 minus 0. 6.
And clearly, we have a circle here whose equation is x minus 2 whole square plus y square equals 2. Taking all these terms to the right-hand side gives me 10. Is it clear to you?
Yeah.
So now we can say that the equation center of the circle is 2, 0. Is that clear to you? So we get the point C, which is the center of the circle. Now it says, show that L, the line, which is y equals 2, 3x minus 6 passes through the center. So basically, if I write, for example, 2 in this equation, right? So if I write x equals to 2, what do I get? I get y equals to 3 times 2 minus 6, which is 0, correct? So we know
Which is
which is the
the center.
point 2, 0, the center. And therefore, we can show that it passes through the center, right? So we have done part A, which is to show that the line passes through the center. So basically, find the center point, substitute into the line equation, right? So, and then, prove it. So this is the equation of the line, which is y equals to 3x minus 6. And we say 2, 0 satisfies this equation. You could say that also.
Okay. Just a little statement underneath.
Yes. So
Okay.
you say the point C, which is 2, 0, satisfies
The equation.
the linear.
Equation of 3x minus 6.
Yeah, you can write anyway. Now,
Mhm.
so this part is absolutely clear, right?
Yes,
So
yeah.
now, part B is find an equation for each tangent to C that is parallel to this line L, right? So basically, now parallel means what? We definitely have two tangents. So one will go like this, correct? The other one will go like,
Same,
do you see that?
same gradient.
The lines really look parallel, no?
No, they do. Yeah.
I love drawing actually. So you can see that.
Yes, very accurate.
Yeah.
I
So
like that.
basically, we did get something. And how do you find the equation of these lines?
So,
Well, we know slope of each line, because they are parallel, is same as slope of
same.
this line, which is 3, correct?
Oh yeah.
Now, the only thing here is to find those 2 points. So what is going to be your approach? We know that the radius is square root 10. Do you see from the circle?
Mm,
R is, let me write down here, R is square root of 10 from the equation of the circle which we get. Is that okay?
yeah.
Distance from here, the shortest distance to the line is square root of 10. Now,
Right.
that can actually help you to find a point through which this line will go. So general line for you is definitely, you can say y equals to 3x, because the slope is same, right? Gradient is same. 3x
3x
plus some
plus
constant.
C. Yeah.
We need to
Okay.
find the value of k. We need to find the value of k, correct?
Mm.
Which you can find provided you know these 2 points, correct? You know the center point and you know the distance from the center point.
So do you have to do plus or minus the?
Once you
root
use
10?
distance formula, you can find it, right?
Oh, okay.
Is that correct?
But how do you find the point that you're like going to?
Okay, so the midpoint here is known to us, and let us say this point is x1, y1, and
Yeah.
that point is x2, y2. Is it okay? So let me erase this all. You have this proof, right? Let's do the second part, okay?
Okay, yeah. Let me draw something.
Yeah, draw your circle.
It's hard to do without drawing, I think. I think you have to make a diagram.
Correct. So let's sketch this diagram. So we got the center C as 2, 0.
Yeah.
And we also know that the radius is
Y equals 3. Radius is root 10.
root 10. Square root 10. So the 2 points, let's say, are PQ.
Okay, so this point here is PQ, and the other point is
X1, Y1, X2, Y2, right? So we know the distance between center and PQ, that means the distance PC is equal to how much? Well, let's find square of this. It'll be easy because square root 10 square will be 10, correct?
yeah.
So basically it is equals to x1 minus 2 whole square plus y1 square. And that should be equal to 10. Is it okay? the distance between these two. So we are using the distance formula here, right? Let me write distance formula.
Oh
With
yeah.
the square root
You're
of
just not square rooting
x1
because you want to
yeah,
use
yeah,
10.
yeah, correct. So we can say x minus, we can say x1 minus x whole square plus y1 minus y whole square root, correct? So if I square this, I get that result. Is that okay?
Wait, so how come you're not doing x1 minus x2?
I
It doesn't
mean,
matter.
it doesn't matter. I mean, because my point is common, that x, y I'm taking as c.
Oh, I see. Okay.
Yeah, yeah. So I just, because in both the
Right,
cases
right.
I'm using the same, I use it. So we know c is 2 zeros. So therefore, PC, P to C, the radius R, is equal to x1 minus 2 whole square plus y1 whole square. So that is one equation. Similarly, the other equation for us is x2
So QC.
minus 2 whole square plus y2 whole square is also 10, right? Because they are the radii. Right? One, we have got this equation. Second, we also know, well, as you see, this is kind of same equations. We also know that the midpoint is C, right? So therefore, I could also write x1 plus x2 divided by 2 is equal to what? Is equal to the x value 2. That is the midpoint.
2.
So
Oh,
we
yeah.
get this equation x1 plus x2 is equal to 4, right? Similarly, y1 plus y2 is equal to the 0 times 2, right?
0. Yeah.
So we have y1 plus y2 as equals to 0. So we have that also. And the other equation which can help you is the slope also, which can help you. I'm just trying to get the equations together so that we'll use the ones which are easier to use.
Yeah.
Easier to use. So another is the slope equation, right?
So the gradients will be the
gradient,
same.
right? So we say that the gradient of this, which is y1 minus 0 over x1 minus this, what do you call this? X1 minus 2 should be equal to reciprocal of the gradient, which is minus 1 over 3. Is it okay? Because this slope m is equals to 3, right? So slope of this PC, m of PC is equals to 1 over minus 1 over 3. Is it okay?
Yeah.
So that gives you 3y1 equals to minus of x1 plus 2. Is it okay? Is it okay?
Yeah, yeah.
So we have got many combinations, because now I can use one of my equations, use this 3y1 equals to this, substitute and get the result. Is it okay?
We'll substitute y1.
The first one. So yeah, we could substitute in y1, or because why should we complicate it further? I can say x1 is equals to 2 minus 3y1. Is it okay?
Oh, yeah.
I'll substitute x1 here. So now I'll
x1
substitute
equals 2 minus
x1.
3y1.
Yeah, so that will simplify, right? So x1 equals to 2 minus 3y1 minus 2 whole square plus y1 square equals to 10. That is simpler. You see that part? So once you work with many equations, you know what to fit in. Correct. We have many. Now 2 minus 2 is 0. And we get minus 3y1 whole square, which is 9y1 square plus y1 square equals to 10. 9 plus 1 is 10. So 10y1 square is equals to 10. And we get y1 equals to square root of plus minus 10 over 10, which is 1, which is plus minus 1. Do you see that?
Yeah.
So we get the value y1 as 1. And so x1 is equals to 2 minus 3, which is minus 1. Is it okay?
Yeah. So, you know, from x1 equals 2 minus 3y1.
Yeah.
Can you sub in the x1 value?
Yeah, I will do that. So I used one value, which is plus 1. And then I'm saying x2 will be equals to 2 minus I'll use -1 this time. Is it okay? Which is
Okay.
5. Do you understand?
Sub into
2, right? So we get 2 quadrants. So we actually solve for both of them. I will explain you this. This become complicated because of the space here. Okay. Let me write down, then I'll explain. Okay. So I
Okay.
get 2 points. Which one is -1 with 1, and the other point is 5 with -1. Do you see that? Okay. So let's summarize. Let me just tell you what I did. Okay.
Okay.
So from the figure, it is very clear that P and Q could be 2 different tangential points where the lines parallel to the given line could be tangent to the given circle C, correct?
Yeah.
Now, these points are square root 10 distance away, and therefore we use the distance formula that P to C distance, square of that is basically equal to x1 minus 2 whole square plus y1 square equals to 10. So we use this
Right.
equation. Let's call this equation as 1.
Yeah.
Second, we know that the slope or the gradient of the radius and this line will be negative reciprocal. And therefore, we know that the slope of PC should be equal to -1/3.
Right.
And that is y2 minus y1 divided by x2 minus x1. So y1 minus 0 divided by x1 minus 2 should be -1/3. So that gives me a relation between x1 and y1. So
Yeah, I
using
see.
these 2 equations, this is equation 1, this is equation 2. I'm able to eliminate x1, write x1 as 2 minus 3y1 in that equation and simplify. Do you see that?
Yeah.
Fortunately, 2 minus 2 becomes 0, minus 3y1 whole square makes it to 9y1 square plus y1 square, as you can see on the screen, is equal to 10. 10 y1 square is 10. That means y1 could be plus or minus 1, right?
Oh,
So
yeah,
we
I'm
get 2
following
values
now.
of y1, right? So we get 2
Mhm.
values of y1. We are saying y1 equals to plus minus 1. Now for each value, we can find x value using this particular equation. So when I substitute it -1, when I substitute x as the y value of 1, I got x as -1, right? 2
Yeah.
minus 3. So I got 1
And
coordinate point. And when I substitute -1, I got 5.
5. Yeah. So you got 5 minus 1.
Correct. So this point for me is the x value of -1 and 1, and this value here is 5 and -1. Is it clear to you? Makes sense?
Oh, yeah. Yeah, yeah, yeah. So 5 minus 1 and -1, 1.
Correct. We did not use this formula of midpoint. However, you can use this to check your result. If I write
No,
x1
yeah,
plus
but it's
x2
really
divided by
helpful
2,
to,
yeah,
yeah,
you
it's
can
really
use
helpful
this
to see that too.
check result.
Oh, okay. So check result with using midpoint formula.
Correct.
Okay.
Amy, you can see, actually, I could have approached from the midpoint also to solve this question. But this was a better approach. Using the gradient was a better approach. So we used distance and gradient, but we could have used the midpoint formula also to find those 2 points.
Oh, okay. So I think let me go away and see using the midpoint formula and see if I also get the same and see which one was better.
Slightly complicated. Yes. Now, midpoint formula itself is a challenge question. Sometimes what we do here is we give you conditions, says this and this is known to you, find the other points, which are so much distance away. So that is this question. So that is a very relevant question where distance and the other 2 points we have to find. Is it okay?
I see. Yeah.
And there is from a point, how do you find distance to a line? That formula is not known to you, but I can share that with you, right? So
the external point one.
Is this clear to you? I can clear the screen.
Oh, wait. So just a quick thing. So when you want to find the equation of each of those, do we just have to put it into the like y equals 3x plus c form and then find subbing in the coordinates?
Okay.
Because the question's saying.
let me explain this in the way we did really do this question. Okay, so let me just sketch this once again. So we had a circle here, and we had lines which were tangent, right? You don't always get them tangent, see? Right, but we'll assume them to be parallel and tangential. Is it okay? We are calling these points as P and Q, the center being C. We found C as 2, 0. We are assuming point P to be x1, y1. Is it okay?
Yeah.
So first is, we found that this radius here is square root of 10 because of the equation of a circle which we derived. Is that clear?
Right.
Right. So from this. So basically from this we get all that information. So we know that the distance from P to C is equal to square root of 10. So square of that distance is how much? So square of that distance will be 10, which will basically be x1 minus 2 whole square plus y1 minus 0 whole square. So that is equation number 1, correct?
Yeah.
The second equation which we got was from the gradient of the line. Let's write M, PC is equals to negative reciprocal of this line, correct? So minus 1 over 3. Because it is perpendicular to your line. Is it okay?
Oh,
Equation
yeah. So
of
we
this
found the
line
gradient
is
of
y
PC.
equals to 3x minus 6, correct? And therefore, the
So-
gradient of perpendicular is minus 1 over 3. Is this clear?
So that's PC.
PC. But the
Okay.
PC is y2 minus y1. You could do that, right? Over x2 minus x1 equals to minus 1 over 3. Y1 is my actual value and 0 is the other value, right? So, and the value is x1 minus 2, right? Is it okay? Equals to minus 1 over 3. And then you can cross multiply, right?
Mhm.
When I cross multiplied, I get 3y1 equals to minus of x1 plus 2. Is that okay?
Yeah.
So I'm writing x1 as equal to, bringing it here, 2 minus 3y1. Correct? So now this is my equation number 2. I am substituting 2 in 1.
1.
So when I do that, I get 10 equals to, x1 is 2 minus 3y1, and we already have minus 2 whole square plus y1, correct? Whole square. So that is 10 equals to, 2 and 2 cancel, minus 3y1 square is 9y1 square plus y1 square, which is 10y1 square. Correct? 10 equals to 10y1 square. That gives you y1 as equals to plus and minus 1. Now, we can apply the value. Y equals to plus 1 and y equals to minus 1. And we have this equation, x equals to 2 minus 3y1, right? So 2 minus 3, 1, which is 2 minus
1.
3, which is minus 1. And if I do 2 minus 3 minus 1, we get 2 plus 3. Is it okay? Which is 5.
Yeah.
Is it okay? So the coordinate point will be 5 and y value of minus 1.
Minus 1. Yeah.
First one is minus 1, 1, right? So we get this as minus 1, 1, and we get this as 5 minus 1. Is this clear to you? Simple as that. Now, I also said...
Simple. No, it is simple. It's just long. That's all.
Yeah, if you see now the solution,
Yeah,
right, you figure it out, it's not very difficult.
No.
Strategy, right? Now you can check the result very easily because this being the midpoint, right? So if I do x1 plus x2 divided by 2, what do I get?
Oh, you should get
Minus 1 plus
2.
5 divided by 2 is what? 4 by 2, which is 2, correct?
Oh,
That's what I'm saying, right? Y value, of course, plus 1 minus 1 divided by 2 is 0, right? So that is y value. Is it okay now? So it is a check that that center goes through these 2 points. Perfect. Such a simple I mean, layout of the whole solution. Perfect.
Definitely, yeah. Yes, it's really clear. So when it says find an equation for each tangent to see, do we then need to find?
Yeah, let's find the equation of the tangent now. So let's clear this. We know that the 2 points, as we just figured it out, were, let me now just draw these and write point P and point Q. Can you tell me the points, please?
So P was -1, 1, and Q was 5, -1. 2, 0. Yeah.
Very difficult to get a line when a point is given to you, right? Y equals to 3x minus 6. So these two lines will be what? This will be
So
y equals to
y equals 3x plus c.
Right, you can say anything, right?
Yeah.
So y equals to 3x plus c, right? So we'll just substitute the point. We have
And then
y
you get the
equals
equation.
to 3x plus 2. We know one point which is -1 and 1. So 1 equals to 3 times -1 plus k. So 1 plus 3 equals to k, which is 4. 4. And therefore the equation is y equals to
3x plus 4.
One equation. The second one, you can again do the same calculation. Y equals to 3x plus c this time. And your points are -1 for y and 5 for x. So bring it on this side. -1 minus 15.
15.
C minus 16 is c. And therefore, the equation is y equals to
3x minus 16. Wow. Yeah.
So now you're done this part. Amy, good selection of questions. Very good.
Wow. Yeah, so now at least when I see this question, so we've done obviously the classic one where you find the center, find the radius, and always that external point, or there's a tangent, but I actually haven't done this question where they say two tangents parallel. So yeah, the whole method of approach was obviously deriving the center and the radius just from that equation that they've already given. Then you've already got the gradient. So this was the gradient approach. So we wrote down the midpoints, but that was used to check your answer. So that's really helpful,
Yes.
like super helpful, because otherwise there's no other way to check. But then we used our distance formula along with our gradient and then solved. So yeah, at least now I know the strategy. So if I see a question like this again in the future, I know at least how to approach it and I won't be just stuck. Yeah, because I'm always stuck on these questions. Yeah.
So remember, in the examination, it is very important to check your result using some simple calculations and strategies work. How do we check? That is very important, which we are learning apart from solving questions, okay?
Right.
So let's clear this and take some other question, please. Any other question you want?
Okay. I mean, we got either this question or there's a final maybe integration question. So you can.
Okay, so I'll give you a hint for solving. Let's say move and let's see what the question is. If the time doesn't, we have 15 minutes. Okay. Yeah. I cannot read the top. Okay. Slide, if you could adjust. What is that written there?
Sorry.
Yeah, that's fine. Can you please read?
Yeah, so figure 3 shows a design consisting of two rectangles measuring x centimeters by y centimeters, joined to a circular sector of radius x and angle 0.5 radians. Given that the area of the design is 50 centimeters squared, part A, if I move down, it could mess up your...
Doesn't matter. Oh, I'll remove this. Don't worry. Nothing will get
Sorry.
gone.
Show that the perimeter p centimeters of the design is given by p equals 2x plus 100 over x.
So, Amy, we are given the area, right? So, can you find the area of this figure? So, we know the area is 50, correct? What is the area of this figure? Quickly, can you tell me? These two rectangles.
So, you have
xy.
2xy.
Yeah, you did 2xy. Good job. Let me write xy and xy. Plus, what is this sector?
Nope. So half r squared theta. So half times the radius is x.
What is the formula?
Half r squared theta.
So sector area is half r squared theta. Add that sector area, which is half of, and the angle should be in radians as given here, right?
Right. Yeah.
And x is your radius, x squared, and 0.5. 0.5 is also half, correct?
Make that whole thing equal to 50, and then I guess go from there.
Yeah, make that whole thing equal to 50. We got two parameters in this, which is 2xy. Let me rewrite again. 2xy plus half and half is 1/4, right? X squared equals to 50, right? Multiplying by 4 and isolating, we can get the value. We want function in terms of x, right? You mean
Right.
you need to isolate y. Is it okay?
Yes, yeah.
So
Make y the
first,
subject.
correct. My y is okay. So let me just multiply everything by 4 first. 8xy and
Plus
equals
x squared.
to 50 minus x squared. Is it okay?
Oh yeah, yeah.
So y equals to, so it's a 50 over 8x minus x over 8, correct? X and x
Oh,
will
yeah.
cancel, x over 8. So we get y equals to this, correct? Now what is
Yeah.
the perimeter?
So x plus
We
2y,
got x, y, 2
2x.
plus, so we got x and x,
Oh,
x,
2x
right?
plus 2y. No, 1, 2, 3,
4y.
4y. Yeah.
Plus, what is r theta?
It's
X into
length
0.5.
times theta.
Yeah, so arc is r theta, right? So radius is 6, x,
Oh, yeah.
radius x, theta is how? So that is your perimeter, right? So the only thing which you need to do here is, let me just write 2x plus half x, and instead of y, we'll write all that, 4 times this. So we have
And then
plus
you would get that
4 times
answer.
50 over 8x
Minus x over 8.
x over 8. Is that clear to you? When you
Mhm.
multiply, you get what? 2x plus half x plus, when you multiply by 4, you get 50 over 2, which is 25 over x, correct? And
Yeah.
that is minus x by.
Minus x over 2.
And now if you just simplify, there's one x in the denominator, right?
You
And when you combine all the terms, right? So I think you will get this particular formula.
you will.
So you can see here that half x and half x cancel, correct? Did we miss something? 8, 4 times 8, 25, that denominator thing. So we did some calculations. We got 2x. This term is not 100. So you look into this. Why this is not 100? Arc length is r theta, r into x, 2x plus 4y, 4y, x. Sorry, this was x square. Oh, x square got cancelled with x, right? X square, x and y. Okay.
Yeah.
50 over this, 50 minus. Okay. Anyway, so Amy, what you need to do is, we already got.
I understand the method. Yeah.
So we'll just, so this is a hint for you. Is it okay now?
Yeah.
And because you are given this equation, you can always derive. Perfect.
Right. It's to show that question. Yeah.
Yes. Somewhere we missed 4 into 800. Somewhere we missed one term. I don't know where. 4 into y, and somewhere we missed that term. Anyway, y terms of 1, 2, 3.
Oh. Oh
Yeah.
no, sorry. I thought I had it. I didn't.
No, that is 200, and but there's 8 in the denominator. That
No,
is
200 divided by 8 is 25. So
yeah, so not 100, right? We want that to be 100. So anyway, I mean, you redo it and then submit your answer. Is that clear?
yes. Yeah.
No problem. You just redo it and submit your answer. Perfect.
Okay.
Let's take the other question which you have, which is integration involving question. We'll look into that hint also, okay?
All right. Yeah.
Now, coming back to that question, let's look into that question once again. And let me just, yes. Very important strategy. We'll talk about strategy now, okay?
Need to find it. Sorry. This one.
Yeah, yes. So let's see part B and C. Let's go to part B and C.
Oh, okay. Part B.
Yeah,
Find the value of x for which p is a minimum.
Correct. So now, let us say you could not do this, but that is given to you, right?
Right.
So you can do part B, C, D. You get the idea.
Right.
Part B, C, D is 4 plus 2 plus 2.
So you marks.
Still get 8 marks without even getting the first answer correct. I'm not saying don't do it correctly, but I'm saying that right.
You're just saying, yeah.
We got something which was close enough, but we did some mistake. We have to figure it out. But now, find the value of x for which p is minimum. That means you just do the derivative of this, which is 2 minus 100 over x squared, correct?
Yeah.
And when we say minimum, we are finding the critical number, correct? So you can find the critical number. 2 equals to
make that equal to
100
0.
over x squared. So x squared equals to 100 over 2. And then when you do square root, obviously we are taking plus values here, correct? 50 square root 2. You have to also prove that taking 2 points that this is a minimum. Is that okay? So prove
So
to the
the
minimum.
second
You could do
derivative.
second derivative, and second derivative should be positive to give you minimum, right? So
greater than 0. Yeah.
double dash should be greater than 0 at the
For
critical number, at critical
minimum.
number. Okay?
Yeah.
So you do this part. Last part is what? Find the minimum value. Oh, okay. So when you plug this value there, you'll get your minimum value in this form, k square root 2, right? So square root 2, because we had 50 square root, correct? So we have a square root term. Do you see that? We have 25 times 2. So we do have that square root term. And so you can figure this.
So 5 root 2. Yeah.
Somewhere else, you understand now, correct? So find the minimum value of p in this form. Yeah, 5 root 2. K is 5, correct? We got the answer. So
That's
was
nice.
great.
Yeah.
What I'm trying to say here, once again, if by any chance you make a mistake and don't get part A, you can still do part B, C, D. Simple.
Right. Yeah, don't just like avoid the whole question. Totally.
Do not miss these marks.
Yeah.
Underline it. Is that clear?
Right. Yeah.
Okay.
And then you can just always go back and then check part A again. So it's not that. Yeah.
Move forward and at the end come back to this and check your result. Okay.
Yeah.
Even if you give that wrong answer, the invigilator, the teacher will understand where you made a mistake. And
yeah. And you always get method marks.
Method, right.
Yeah.
Yeah.
Because you can get error carried forward. So that's all right. Yeah.
Okay.
Okay.
Yes. Last
one
question.
More question.
Any question you want? Yeah, one more question we'll take. Again, go quickly through it. Okay.
Okay.
Oh, that's
let's end on a good question.
Okay, let's read the question. It's integration, right? Whenever you see area under a curve. Perfect. So
okay. So figure 2 shows the curve C with the equation y equals 3x minus 4 root x plus 2 and the tangent to C at the point A. Given that A has x coordinate 4, part A, show that the tangent to C at A has the equation y equals 2x minus 2. Oh, wow. 6 marks. And then part B is the shaded region is bound by C, the tangent to C at A, and the positive coordinate axes. So part B would just be find the area of the shaded region.
Got it. So how will you do it, Amy?
Okay. So I know how to do part B, which is just using integration, and then you can find the area. But part A, let's see, show that the tangent to C at A has the equation.
So part B is clear. Amy will do part A, which is 0 to, you know, the value 4 also, correct? That's the beauty.
Right.
And you have this equation, which is 3x minus 4 square root of x plus 2.
Plus 2.
Yes, right? So you get this definite integral, get your part B done. Is that okay? No harm in doing part B first and then going for part A.
True.
Right?
Okay.
At least you got 8 marks, right?
Yeah. I always have that feeling in an exam where I don't know, I feel like I have to do part A first, but technically no. If I can do part B quicker, then you might as well. Because I know I'm going to spend a while on A, right? Just by looking at it, I know. So yeah, it's important.
I mean, critical thing is, by the time you come to the last question, you are running out of time and you have very little time with you. Why not get first this 8 marks? And then go for the other part, which is longer.
Right.
Kill it. I mean, it is an examination. It is also seeing your strategies to work out. Let's say you have only 1 minute to go. This is what you'll do. 1 minute, get 8 marks.
Yeah. It's kind of like you have to play the game right, you know, because I guess everyone obviously going can, or writing the exam, knows the strategy. Let's say you're like really like high up. So if you want to like kind of beat your opponents, you have to kind of think strategically to, get the best marks.
So, okay, now let's find this. This is also not bad. We know that y is equals to 3x minus 4 square root of x plus 2. So y prime, which is the derivative, will be what? 3 minus 4, and that is 1 over 2 square root of x, right? This is 0. That is the derivative, correct? We are already given that x is equal to 4 at point A, right? We are given that. So plug that up. So y dash at x equals to 4 is what? 3 minus 4 over 2 is 2, right? 2 over square root of 4, correct? So we get 3 minus 2 over 2, which is what? 3 minus 1, which is 2. Right, so we got this value. We got the slope as 2, correct? Sorry, we got the slope as 2, which is this one, correct? So we know that the gradient m is 2. And therefore, the equation of the line should be y equals to 2x plus c. Is that clear to you?
Wait, so when you find I think I've asked you this last time, but when you find the gradient of the curve, you get the tangent.
The slope of the tangent, yes.
Oh, honestly, I don't know why I don't understand that.
So this
Wait.
is the slope of the tangent, right? So m, slope of the tangent, is basically 2 for you, correct?
Oh, okay.
You have to
Okay.
find the point y, so plug in 4 here. So you get y is equals to, plug in 4, which is 3 times 4 minus 4 times square root of 4 plus 2, which
Oh,
is
to get the y
12
value. Yeah.
minus, this is 2 times 4, which is 8 plus 2, correct? 14 minus 8 is what? 6, correct? So you
Yeah.
get 4, 6 as your
So
point.
4, 6. And then you sub that in, get the value of
In this
C.
equation, find C. Is that clear to you?
Okay.
You can
Wait,
get-
so I still don't understand why the gradient of the curve is the gradient of the tangent.
Yeah, because that is at gradient derivative of
Yeah.
a function. Derivative of the function gives you the tangent at every point. So if I are looking only at point A, the derivative of A is actually the tangent at A.
Oh, okay.
So therefore,
Okay.
it is the slope of the tangent line. So when you
Right.
plug in x is equals to 4 in this particular equation, and you know the value of y is 6, you get what? 6 equals to 2 times 4 plus c, right? So 6 minus 8 is equals to c, which is minus 2. And therefore, you get the equation, which is y equals to 2x minus 2. Is that clear to you? Done.
Yeah.
So I quickly did all this. We are running out of time. 1 minute left for us to complete today's lesson. Emmy,
Right.
can you just summarize this in a minute's time?
Oh yeah. So what we did was when I personally just looked at this question, I just found finding the area of the shaded region is just area under the curve, straightforward integration. So I just kind of went straight toward that, and it's no harm in doing part B first, and plus it's got more marks, so you might as well. And then part A wasn't that hard. I don't know. I just that was a personal thing. So
Yeah.
then part A,
It
trying
looks
to show the
harder. It
tangent.
looks harder, yeah.
Yeah, it looks harder. I don't know, but I think it's whole tangent business. So it's just finding the first derivative of the curve equation, because that would give the gradient of the tangent. Then when you find the gradient, like straightforward, you get the gradient as 2, and then you just do y equals 2x plus c. And we know the point A, they've given in the question, the x coordinate is 4. So find the y value by substituting 4 into the curve equation, which is y equals 3x minus 4 root x plus 2. Get your y value, substitute the coordinate into the equation, and you get y equals 2x minus 2.
Perfect.
So
very well done. So basically, when you read this question, first step should be, you know the x coordinate, correct. Find the y value.
right.
That is the first thing you'll do, right? Because you
Yeah.
should know the point A. Now, second thing which you want to do is find the derivative, because we are going for equation of a tangent line at A. So you need to find the derivative at A, x equals to 4. Once you find the derivative, you have equation y equals to mx plus c. M is the derivative at 4. And to find the value of c, just plug in 4 and 6, the xy value of A, and get your equation, which will be as given to you, right? The beauty of your test is answer is given to you. So it helps you to figure out the right answer.
Yeah, and you know what's funny? These show that questions are always like so many marks, and they've given us the answer, but it's always the show that ones are like 8 marks, 6 marks. So it's really good to get in the habit of, like, even other people who are out there doing this EdExcel exam board, to answer these questions like perfectly, because you know the answer. So the only thing is to get it right. So yeah, it's really good.
Great.
Okay, well, thank you so much, sir. This has been super helpful, going through integration, circles, and logs, the 3 hardest topics for me, and I guess for others as well, which is really tricky. So yeah, and a bit of circles and trig. So yeah, thank you so much.
Thanks for sharing such beautiful questions. I really loved them, and it was challenging also to do them. But I think we learned a few good strategies. How do we do? We could do part B, C, D if A is not done correctly.
Yes.
How, correct? And apply different strategies to check your answer, so that you are 100% sure you're fine. Takes few seconds to check your answer. It's worth it. Because if there is
Definitely.
a mismatch, you can go and check your calculation, man.
Yeah,
That
yeah.
is possible. You could do. We also get one error somewhere, right? We have left it for you to
Oh, yeah.
figure it out, right? And we
I will do that.
Okay, great then.
Yeah.
Okay,
And
then.
also, sir, the proof question.
Proof question.
You know, the one when you said if and then, you know, it
Yeah.
doesn't, if it's not a straightforward like statement, use mathematical way to prove it, not like counterexample or exhaustion method.
So
So, yeah.
simple English problems, go with counter
Simple
examples
method.
and all.
Yeah.
Otherwise, it is more algebraic in nature. Okay.
Right. Okay. Thank you so much, sir.
Great.
Have a
Thank
good
you.
rest of your night. Bye,
You
sir.
too. Thanks. Bye.
Bye.